Good morning, all my dear students of Primary 6. Back to Unit 1, Lesson 1, which is Mass and Weight. If you see this device, what can we say about the name of this device? This device is a spring scale that we talked about last time, and we said that the spring scale is a measuring device of weight. And as I mentioned before, this is the top hook, and here we have the bottom hook. At the bottom hook, we can put the object that we can or we want to measure its weight. And the question now, if I have two objects, the mass of the first object, for example, mass of object A equals 30 kilograms. Another object whose mass is I'll call it object B. So I have two objects, object A and object B. The mass of object A is 30 kilograms, while the mass of object B is 40 kilograms on the surface of the Earth. The question now, which one of them will have a greater weight? The weight on which one of them? The weight for object A or object B? We know that we have some factors affecting the weight. One of the most important factors affecting the weight is the object's mass. The object that has a greater mass will have a greater weight according to the rule, weight of the Earth, the weight of an object on the Earth's surface equals mass multiplied 10. So it will be 40 multiplied 10, it will be 400. So the weight for object B, whose mass is 40 kilograms, will be 40 Newton according to the rule, weight on the Earth for any object on the surface of the Earth. The mass of this object equals, the weight of the object equals mass multiplied 10. So it will be 40 multiplied 10, it will be 400. For object A, I mentioned that the mass for object A is 30 kilograms. It will be 30 multiplied 10. It will be 300 Newton. 300 Newton according to the rule. The weight for object A, its weight will be mass multiplied by 10. It will be 300 Newton. And as I mentioned before, for object B, its weight will be 400 multiplied by 10. It will be 400 Newton. So, by increasing the amount of matter, by increasing the mass of the object, its weight increases and vice versa. This is for the first factor that we mentioned before. Now we can see a figure showing a person sitting below the tree or under the tree, under the apple tree. The apple fell down. He asked himself, is there any force attracting the apple downward to the earth? It was the gravity force, as we explained before. So the weight or the gravity force is a force by which a body is attracted to the earth. As we explained before, these kids jump up when they fall down due to the gravity force that attract their bodies downward to the earth. So, the reason for the objects fall down towards the earth is the gravity or gravitational force or the weight. So, the objects fall down towards the earth due to the gravitational force or due to the weight, as we explained before. And the measuring unit of weight is Newton, as I mentioned before. In appreciation of the great scientist Newton, it is named Newton. So we have only one unit for the weight, which is Newton, but for mass we have two different units. One of them for the small mass is called gram, another one for the great mass is called kilogram. So how many units are used? How many measuring units are used for the weight? We have only one unit, which is Newton. The measuring device of weight, as I mentioned before, this is a measuring device of weight, which is called the spring scale, top hook and bottom hook. Here I put the object that we want to measure its weight. If the mass, or when the mass increases, the weight will increase, and this device is a digital one. Here we can see a digital screen, and the weight of the object will be written here in the form of digits or some numbers, followed by the unit Newton. So this is the spring scale, as I mentioned before. As a quick revision for what we said before, for an object whose mass is 1 kilogram, its weight will be 10 Newton, according to the rule. Weight on the earth, the weight on the earth equals mass measured in kilograms. Don't forget that the mass should be given in kilograms multiplied by 10, and the resulting number will be followed by Newton. For example, this object has a mass of 1 kilogram. 1 multiplied 10, it will be 10 Newton. 2 multiplied 10, it will be 20 Newton. 3 multiplied 10, it will be 30 Newton, and so on. So, as we said before, by increasing the mass of the object, its weight increases, and vice versa. And it was an activity to conclude the main rule which is used here, which is the weight on the earth equals mass multiplied by 10. Okay. Now to one of the factors affecting the weight, which is the object's mass. And as we said before, the object's mass is one of the factors affecting the weight. As the mass of the object increases, its weight increases, and vice versa. For the problems, the mass of a person on the surface of the earth equals 70 kilograms. Before you answer, you have the value of mass equals 70 kilograms. Calculate the weight of this object, or calculate the weight of this person on the earth's surface. We all know that the weight on the earth equals mass multiplied by 10. So we have the weight of the person on the surface of the earth equals mass measured in which unit? Before you answer, try to be sure that the mass is given as kilograms. So, weight of the person on the earth's surface will be mass measured in kilograms multiplied by 10, and the mass is given here as 70 multiplied 10. It will be 700 Newton. This is for the answer of this question. So, the weight of the person on the earth's surface equals mass multiplied by 10. It will be 700 multiplied by 10. Sorry, I mean it will be 70 multiplied by 10, or 70 times 10. It will be 700 Newton. Now to another question. And as we mentioned it before, we have an object on the surface of the earth whose mass is 500 grams. 500 grams. The mass of this object is 500 grams. Now you cannot answer the question in a one step. Before you put the rule, you should change this unit into kilograms. How can I change from grams into kilograms? The value of mass, I mean 500 grams, will be divided by 1000. It will be 0.5 kilograms. Now I can take this value, and in one step I can answer the question here. The weight on the earth equals mass multiplied 10, or mass times 10. It will be 0.5 times 10. It will be 5 Newton. So the idea of this question is to change the unit from grams into kilograms before you answer. So, as I said, my dear students, this is a quick revision for what we studied last time. And now it's time to test yourself. Calculate the weight of an object on the Earth's surface if you know that its mass equals 30 kilograms. Now you have 1 minute to try to answer this question. I'm waiting for all of you to read it well and to try to answer it yourself, okay? Okay, let me help you. Calculate the weight of an object on the Earth's surface whose mass equals 30 kilograms. I said before you answer the question, you should be sure that the value of mass is given as kilograms. So I can answer this question in only one step. The rule which can be used here, the weight on the Earth equals mass in kilograms multiplied by 10. So it will be 30 times 10, it will be 300 Newton, and this is the answer for this question, and please try to answer it. Thanks for watching. See you later in other videos.